Hello everyone, welcome to the video lecture series of operating system. In today's session, we are continuing with the topic memory management. Myself Kunal Panchal, your instructor. In this particular session, we are going to discuss the concept of virtual memory. So before going to discuss the concept of virtual memory directly, first of all, we need to understand the significance, or we can say advantage, of virtual memory. So what we can achieve with the help of virtual memory concept. So the virtual memory concept provides illusion to the programmer that a process which is larger than the size of main memory can be executed in the CPU. So this is the one advantage of, or you can say significance of virtual memory. Second advantage is, irrespective of the number of processes, we can provide the illusion in which all the processes are executing in the main memory at the same moment of time. That is the another significance of virtual memory. Okay, so how we can achieve this concept? Let us discuss in detail with the help of one block diagram. But before going to discuss that block diagram of virtual memory, I strongly recommend it to you to visit my paging session of memory management, because all the concept we are using in this particular session of paging. So if you don't know the concept of paging, it will be very difficult for you to understand the concept of virtual memory. So let us start the concept of virtual memory with the help of this particular diagram, in which the large box, okay, it is represented is nothing but the secondary memory, or we can say hard disk. Okay, so you can see in the right hand side the large, we can say box type of diagram we have that represents the secondary memory of this hard disk. Okay, we have one CPU in this particular figure. Then we have a main memory, which besides the secondary memory, it is located beside the secondary memory. Then we have one page table. So all the concept of paging we are using in virtual memory. So these things you have to keep in your mind. Without understanding paging, you won't be able to understand the concept of virtual memory. Okay, so as I told you, the significance of the virtual memory. So to achieve this scenario, this criteria, so what we need to do is, so as we have discussed in process management, if you want to increase the degree of multi-programming, you need to include more and more number of processes in main memory. But there is one problem while doing such type of thing, because the size of main memory is finite. It means it is limited. So we have 16 GB of RAM nowadays. So we cannot accommodate all the processes of secondary memory into a main memory for execution. It is not possible. Yes. So what we can do? What else we can do in this case to increase the degree of multi-programming, so that we can increase the utilization of CPU drastically? Okay. So if you want to do these things, you have to use the concept of virtual memory, in which what we are doing, irrespective of the size of a particular process which resides in secondary memory, instead of keeping whole process from secondary memory to a main memory, what we are doing, we are, as you know very well, in the case of paging, okay, the same concept is applied over here. In the case of paging, we had the discussion about the fixed size partition of main memory as well as secondary memory. Means secondary memory is divided into fixed size partition, and that partition is called as pages. And same way, the same size of partition will be performed in the main memory, and that partition would be called as frames instead of pages. Okay, so same concept is applicable over here. So you can see in this particular diagram we have one secondary memory, or we can say logical address space, which contains two processes, process A and process B, and these two processes is divided into a fixed size pages in secondary memory, starting from page number 0 to page number 6 in both the process. Okay. Now, as I told you, if you want to increase the degree of multi-programming, or if you want to increase the utilization, so how we can achieve this objective? So what we can do is, instead of putting whole process from secondary memory into main memory, what we can do is we can take few amount of pages, or we can take only required pages, okay, from the secondary memory and put it into a main memory for each process in secondary memory. So what we can do in this case, instead of having all the process putting into main memory, what we can do is, in this particular example, let us concentrate on this particular example specifically, and then you can understand for a general purpose scenario. So in this case we have two processes, so instead of keeping whole process into a main memory, because we do not have that much size in main memory so that we can accommodate these two processes. So what we can do is, to increase the degree of multi-programming, what we will do, we will pick only required pages of this process A and process B and put it into a main memory. And you know very well, the main memory can be accessed with the help of physical address. So that's why it is called physical memory. Fine. And the logical address space, or this is hard disk, secondary disk is accessed with the help of logical address. So you know very well, the CPU always generate logical address through which it can directly communicate with secondary memory, but that operation is very time consuming because of the address space of secondary memory. It is very large. Yes, so that operation is very costly in terms of utilization. Fine. So that is the reason why we have introduced one more